Hey, what's going on, everybody? So today we're going to talk about how to get our camera to follow our player, to follow our ball, and kind of put the finishing touches on this project. So I'm going to show you a few different ways how to do it. Then I'm going to explain the best way. All right, so looking at the screen. So the first thing that we can do is, in Unity, you can nest an object within another object. Uh, And when we do this, it'll share some of the same features. So if I, let's see. So I'm gonna just to show, I have the sphere, then I have another empty object. So what you could do, you could right click, create empty, or you go to game object, create empty, and you'll get something like this. Give it a name, test. And I'm gonna drag this test within the sphere object. And you can just hover over test and it shows you where it's at. So I'm gonna just reorientate everything. I'm gonna go to the right, so it's like somewhere crazy, like under everything. So what I'm going to do, I'm gonna click test, and then I'm going to go to the transform component. Make sure you can see it. All right, so I'm gonna go to the transform components within the test game object, and then I'm gonna click these three dots, and it gives us different options. So what I'm gonna do is resets. So I can reset the position, rotation, and all that. And when I reset it, it'll orientate everything back at its origin. And since it's nested within the sphere, the origin for test, or the local origin, right, would be right where the sphere is. So just to differentiate, I'm gonna just move it a little bit. So I'm gonna click I think the move tool, click on the arrows to move it, or I could change these values. Anyways, so let's see what happens when we do that. So here's my game view, and I'm gonna click play. And I have test selected. So looking at both the game view and the scene view. Wow. So it kind of moves weird, like in a circle. So to show, so I did this to show that, when you nest something, one object inside of another, it seems like the nested object kind of follows the parent object, right? So the one that is nested within, it follows that object like its position. So seeing that, we want the camera to follow the sphere. Let's try this out. So I'm gonna just nest the camera within the sphere. I'm gonna move the camera in like a good position. Let's say I'm gonna move it like right here. I'm gonna move it so it can see. All right, cool. And here's my camera view right here, or my game view. Here's my scene view. And let's see what it looks like. So I nested it within the sphere, and let's click play. Wow. So it did kind of the same thing. Um, what it looks like it's doing, let's look at the inspector. So it's not showing in the inspector what it's doing. Oh, okay. So let's look here. So what it looks like is that it's taking these rotation values and it's taking the position values, and the main camera is kind of following suit with the sphere. But the only thing is we don't want it to rotate. So let me stop this. So one trick we could do, if we want to just leave it like this, we could go to sphere and we can go to the rigid body, right? The rigid body is the thing that makes it act like a real object, which allows it to be acted upon by physics forces, so like gravity, like collisions, things like that. We can give it mass, give it drag, these different things. We can say if it's affected by gravity. Um, One thing let's focus on is constraints. So we can freeze position, we can freeze rotation. So one thing that we could do, let's try freezing the rotation. And let's see if that helps with this camera moving all crazy or going in circles. So let's see, let's just think. So it's rotating. So let's just click the X one. Let's see what it does. So by clicking X, I freeze the rotation on the X axis. Press play, and it's still rotating, but it looks like it's rotating like even faster. Okay, so let's try this again. Let's say freeze it on the Z axis. Wow, and look, it's super smooth. But so let's run it one more time. So that worked out, and the reason that worked, let's kind of look at the transform again. So let's see. Oh, we want to look at rotation, and we froze it on the X and the Z. So let's look at rotation on X and Z, and we see, yeah, nothing's happening. It's rotating on Y, but not X and Z, and then it just stops. Probably because it's hitting this wall, and I guess this wall is going to cause it to rotate either on the x-axis or the z-axis, but we forced that to stop, so there's nowhere for it to go anymore. So this is a solution to the issue of the camera following, but let's say that we wanted to go its full course, like I wanted to go all the way down the slide, and I wanted to be able to rotate in any direction. But I want to actually not be disoriented looking at the ball. So when we talk about that, that's when we get into the coding part. Wow. And let's kind of think about what we want the code to do. So we want the camera to follow the ball. We don't want it to rotate crazy. So we want the camera's position, right, within the transform component to be updated as this ball moves in space. So when this ball goes down 1 unit, we want the camera to go down 1 unit. When it goes to the left, we want the camera to go to the left, in proportion to the sphere. Okay. So we'll go through this, in steps. Um, Yeah, but let's first talk about a few different concepts that are important to figure this stuff out. So the first one being fixed updates. So fixed update, very similar to the update function that you have seen within Unity, right? Update is called for every frame within a Unity scene. So let's say you want to do something for each frame, you would have that code run in the update function. But there's three different types of update functions, and these functions are called um, repeatedly during the Unity scene, but add four different. Now, we won't talk about all three right now, but let's talk about fixed update. So the regular update function runs for each frame of the Unity scene, but the fixed update function will runs in sync with the physics engine of Unity or physics system. So let's say that um, so different physics system calculations are done at as a certain rate, and fixed update will have the same rate at which it's being called. This is important because if you want some code to run that needs to be aligned with something within the physics system, let's say you're adding a force to an object, right? And you want something to happen when that force is applied or during the application of the force, things like that, that will need to be done in fixed update. So anything that has something to do with the physics system, right, and you want it to run repeatedly, that would need to be run in the fixed update. But it's also a case by case type situation because sometimes we need to decide between fixed update and then the regular update function, and that's just something that you'll be able to decide between to see what runs better. But anyways, let's do fixed updates. So I say all that to say, right now our sphere has a rigid body attached to it, and I'm trying to have the camera fall or the camera follow the sphere uh, in accordance to how its position is affected by gravity. So because of that, we're going to be doing our code within the fixed updates. Just because it is the camera is going to be dependent. The camera position is dependent on the sphere's position, which is dependent on the rigid body. Nice. How does that sound? Does that sound all right? Anyways, we're still working on it. So, we figured that part out. Now, the next thing we want to do is create our new script. So, well, first let's move our main camera out of here and let's create a script folder if you don't have it already. So let's right click, create folder, right, name it scripts, and then let's create a new script. See, so right click, create C# scripts. Or I think you could go to assets, then create C# script, and let's name it camera. Let's move. Let's move cam. Right, so it might take a few seconds for it to get ready. And then let's double click it and open it up. Awesome. So now we got everything there. I'm gonna zoom in a little bit. And the first thing we want to do, let's create our fixed updates. So let's do void fixed updates. Nice. And the first thing we can talk about is awesome. So the first thing we're going to talk about or use is the look at function. So this is the Unity documentation websites where you can look at different methods, different code that you can use within Unity. Anyways, so the look at method is within the transform class. We'll talk about classes later, but this is just a system of organizing code. So something to keep in your back pocket. But anyways, look at. So they're saying there's two different ways you can call this method or function. Look at with transform with targets, and target being a transform uh, type, being the type transform. And then this is the other way you could call it, with this one takes two arguments, one being target and one being rolled up. So let's check it out. So target is the object to point towards, rolled up is the vector specifying the upward direction. So description. Rotates the transform so that the forward vector points at the target's current position. Does that make sense? Let's think about it. So basically, it just points the forward vector, so whatever is deemed as the front of the object, it points it at the target's current position. Nice. Then it rotates the transform to point its upward direction vector in the direction hinted at by the world up vector. So yeah, if you leave out the world up parameter, the function will use the world y axis. So it's saying like, hey, normally it'll use the y axis to say, hey, this is the direction of, I don't know, up and down in the world. But let's say you're not using that for up and down. Let's say you have the game or demo or whatever oriented in a different way. Then you can use this argument to specify that. Nice. And then we can go down and see how they used it. And this is how we will use it. So they have a transform object or variable right here. So this is called targets, and this is the type. Let me go back. And this is a type transform, and they transform dot look at in parentheses targets. Nice, nice, nice. Yeah. Okay, so let's try it out for ourselves. And then just FYI, in Unity, you can reference the game object that a script is attached to. You can reference the components within the game object that script is attached to. And you can reference the game object itself without making a variable and assigning that variable to it. But let's work it out. Let's see. Don't look. So let's go to fixed updates and let's try this look at things. So okay, so for one, we wanted to look at our sphere. So let's create a variable and we're going to use that to reference the sphere. And I think maybe you tried it one way, so I want to show you another way how to reference a game object. In this way, you can do it by the name of the object. So let's see. So first, let's make a game object. So I'm just call it private game object because that's the type. And I'm gonna call this one sphere. Okay, but now we need to. Okay, so now we're gonna do set the sphere equal to something. So we're going to do a sphere in the void start method. And remember, this method is only called once per scene. So any in any script that you make, and you have a start method in that script, this method is only called once during the duration of the game, or it's called when that object is okay. Better explanation. So the start is called on the frame when a script is enabled. So let's say you have a game object and a script is attached to it, and as soon as this script is enabled, so when the game starts and the start method will be the first thing called. But let's say you had the script component disabled for some reason, and then you enable it, the start method will be the first thing called. It'll be only be called once, and then it'll be the update method. Nice. I hope that was good. So since it's only called once, and this is a good place to, and it's only called once and it's called first, this is a good place to define things. So let's go sphere, get components, and let's go sphere, let's go get let's go get, let's go sphere, let's go find game object find. Yeah, let's go game object find, and this finds a game object by its name and returns it. Easy. Yo yo. So the next thing we want to do is put our name for our game object within these parentheses. Remember, this is a string, so we'll want the quotation marks to surround the name. So the name of my game object that's going down the slide is called Sphere Ball. Nice. So you can add whatever name that you're using there also. And just to see something, we could write a debug.log statement. So remember debug.log, that'll print it to the console, log the message to the Unity console. And what I did was taking the sphere variable, right, that's representing our sphere ball game object, right? Because remember it's the game object type. Then we're getting the game object using this command or this function, right? And then we can do sphere.name because name is a, let's say, a function or a property within sphere. So we can grab that to output the name. Yeah, so we can just see what that looks like. But anyways, let's go into fixed update. And we talked a little bit about that. Remember, fixed update is what's being called in sync with the physics system. And let's have the first thing that we do is have the camera look at the sphere. Um, all right, and the way we're going to reference the camera, first we're going to say camera dot main. So the main says, hey, we're referencing the actual main camera component. And then we're going to do dot transform to get access to the transform. And then we're going to do look at. Nice. And then within the argument, for the argument of this look at function, we're going to use the sphere transform. So we're going to put in sphere dot transform to get access to the transform component that's attached to the sphere. Let's see. Yeah, so this is one way to do it. There's another way you could write it too, but let's get this running first. So let's save this. If you have any questions about any of these commands, you can feel free to look it up online, like go back to the documentation page, or just search it on the internet. You can always click this. You might not have it for yours. I do have it for mine. Shows you different examples. Anyways, let me exit out. So I saved, and now let's go to the game. So let's attach it to the main camera. So I'm clicking main camera, and then I'm taking my scripts. I already have it attached, but we can click and drag it over, and it'll populate right there. Or you could click add component and then type in the name of the script, and it'll let you add it that way too. Cool. So let's run it, make sure it works. And now you can see that the camera stays pointed towards the ball. Nice. And I was going to say another way we could do this is instead of putting this extra stuff, camera.main.transform, since we have since this game object is attached to the camera, we could just say transform.look at sphere dot transform. We could just say that. And because when a script is attached to the game object, you can just reference the components without having to get the like kind of go down the list or the hierarchy, like getting the game object and then referencing the game object to get to the component. Since this is attached to a game object, Unity allows us just to reference the component. So let's save it and let's see if it works. So it should work the same way. Let's see. And it does. Nice. So that was just another little explanation. Nice. If it's not rolling for you, make sure that you have unticked the this thing. I did have that attached twice. I don't need it attached twice. Nice. But yeah, so you want to make sure that these are unchecked. Okay, cool. So now the next thing we want to happen is we want the camera to move with the ball. And okay, so how we're going to do this is by updating the position of the camera in relationship. Yeah, updating the position of the camera with the change of the position in the ball. So we're going to look at the past position of the ball for each frame. So let's see. So yeah, so we're going to look at the past position of the ball and the current position of the ball. So the past one from each fixed update, right? Look at the past one, look at the current one. Uh, see if there's any change. So find the difference. And we're going to take that difference and then add it to the current position of the camera. Nice. So whenever this moves down one, we're going to take that, add it to this position so it can move down one. Okay. So to do this though, we have to learn a few. We have to go over a few things. One being transform dot position. So the position, we can set a value to that, but the way that we'll do that is through vectors, because the position is a vector in Unity. And if you guys aren't familiar too much with vectors, it's math concept. It's a physics concept that's being used in Unity. And in Unity, the type is called vector 3 for like a 3D vector, or vector 2 for a 2D vector. And remember, and as a reminder, a vector has magnitude and direction. So it'll tell you kind of what direction to take, and let's say the magnitude is kind of like how fast it'll take you to get there, or like the speed you're to go in that direction. Yeah, something like that. So it gives you kind of two different data points, kind of. Yeah, so but anyways, a vector will tell you the direction and the magnitude. Direction being like the direction to go that way. Magnitude being like the speed you should travel, 40 miles per hour. That was like a quick synopsis of vectors, but that's how we'll use them in Unity will be different for each use case, or it could be different for the different use cases. But when we're using a vector to give position, so to edit the position, let's say property of the transform component, we'll be using the vector in a way where each value, so remember a vector is like a compilation of, let's say vector components. So for this vector that we use to set position, there'll be three components. It'll be a 3D vector, and one representing a different, each one representing a different axis. So we'll have the x component, the y component, and the z component for this vector. And they'll just be saying like, hey, this is the points of position. Yes. So this vector will just be telling us, hey, the point of position. Um, we might use vectors in other ways, and for other things, like say we're adding a force to an object, da da da. But this is how we're using vectors in this way. Nice. Okay, so what we want to do is let's first create a little variable, or create a variable. Let's say we want to make it private. Private just being that only accessible to this script, can't be accessed outside of this script. Nothing to worry about right now. And let's make the type vector 3, and you'll just get a little definition if you hover on top of it. Representation of 3D vectors and points. And we can choose a name. So this variable is going to represent the past values of our sphere. So this is going to be what we're finding the difference between this value and its current position. Nice. So in the start method, we're going to get our first value for the past sphere position, or past sphere POS. Right, so we can set it equal to our sphere game object. Remember, let's reference that. And let's do dot transform to get to the transform component, then dot position. I'll type it in with you to get to the position component. So let's see, dot position. So that should pop up for you. And this will, if you hover over, it'll say the world space position of the transform. And it'll show you the type, which is a vector 3. So let's click that to autofill. Semicolon. Nice. So since the start method runs first, we can use that to get our first position for the sphere. And then the order will be starts and then fixed update. So how will we do this then? So let's say first thing we want to do, right? Yeah, so first thing we want to do, anyways, first thing we want to do is let's start setting the value of our camera position. So we can just do transform dot position. Remember, this is attached to our camera. So when I say transform dot position, this is the position of the camera. And let's just set that equal to, let's see what we want to do. Uh, okay, so let's set it equal to the sphere's position. And let's just see what that does, and then we find the difference. So let's go sphere dot transform dot position, right? And this is looking to get a vector 3, and let's just hover over this, and remember position, this will give it a vector 3. So that's the type, right? So transform dot position will accept a vector 3 type, and sphere dot transform dot position is, uh, let's say, providing a vector 3 type with the position of the sphere. Nice. So transform dot position is a property, or it's like a method that acts like a property, but let's just say it's a property, and you can set the value and you can get the value with transform dot position. And that's just determined by what side of the equal sign it's on. If it's on the left side, that means you're going to be setting the value. If it's on the right side of the equal sign, like it is here, it's going to be giving a value. Nice. So let's see, transform that position. Okay, we're getting to the same position of the sphere. Let's see what happens. So let's just run. Wow. Wow. So what's going on? Let's look at the scene view if you weren't paying attention to it also. So the camera is right where the sphere is. See, I'm clicking the camera, then I'm clicking the sphere. They're in the same position. And what I want is for the camera to be a little offset from the sphere. I want the camera to maintain the same distance away from the sphere. And how we're going to do that is by finding the difference between the current sphere's position and the past sphere position. So let's add first. So how I'm gonna do that is I'm gonna do the difference sphere dot transform dot position minus past sphere dot position, and that'll give me the difference. And then let's say it has a value here. It's getting this initial value. Let's just see what happens real quick. Give it a second to load. Oh, it's underground. Now acting a little bit unexpected. And I think that's because this value isn't being updated. It's only being given that value once. That value stays the same. Then nothing happens. So let's try and update that value. Let's see if that does anything. So past sphere equals sphere dot dot transform dot position. Okay, so now we're just getting the difference, and let's see how that works. What do you think will happen? So it's still a little bit below ground. But okay, looks a bit better. And let's just check. So one way, if you want to, kind of see what's going on, let's just hover over main camera, and we can get the update of what's going on. So you see everything's kind of hovering around 0. Interesting. Nice. The rotation is changing because it's continuing to look at the ball. But yeah, keep note that things are around 0. So let's go back to the code. All right, so we're just looks like we're just doing the difference, taking the difference and setting that as the position of the camera. I think the next thing we want to do is include the current value of the camera in this equation. So we take the difference and then we add it to the current value of the camera, which will kind of keep the camera at its position, then take that difference into account, the difference of the ball, and then move the camera using that. And then for each cycle, this will be the past position of the camera, which is kind of what this represents. Transform that position kind of represents the past position or the position from at this, before we make this change right here, before this change takes place. And then we're including this difference. Let's hurry up and run it. Right. Please let me know how this feels for you. How does it feel? Wow! And so this time the camera is following the ball. Do you have any questions? Let's do it again. And I'll make it full screen. Wow! So this way, now we don't have to orientate our camera in some weird way. We can kind of just mess around with it, but we don't need to get any perfect angle because remember, our camera is following our ball. It's going to be consistently looking at our ball, and then the position is going to be updated in correlation with the change of the ball. Wow. I'm so happy we were able to figure this out. Nice. This is a cool perspective. This is a cool view. Nice. So you can move the camera around to see like what works best. And remember the camera will, when you run it, the camera will look at the ball. I think that's good. So feel free to follow along. Awesome. So that's it for that. And um, yes, I think we're done. Thank you.